Hello. The purpose of today's experiment is to investigate the pressure law. In the last lab, we investigated the Boyle's law. Now, what is pressure law? Pressure law says if you have a certain amount of gas enclosed in a rigid container, volume is a constant, and if you increase the temperature, the increase in pressure will be proportional. Now, we have the gas law is PV equal to nRT. When the volume is a constant, the pressure will vary directly as the absolute temperature. So this T is the absolute temperature. That means you will be varying the temperature and measuring the corresponding pressure. How will we do that? I will be covering this bulb with ice in a container like this, and you can measure the pressure using this pressure gauge. Now I will be focusing this pressure gauge for you as we go on. Now you will be using the inner blue scale. That's the blue scale. The inner blue scale is that. There you have 1 atmosphere, that's 1 atmosphere, and that is 1.5 atmosphere, and the interval between is divided into 10 equal parts, which means each division is 0.05. So let me take it closer to the camera and show it to you. Now, this is 1 atmosphere, this is 1.05, 1.1, 1.15, 1.2, and so on. Now, this is in atmosphere, so the pressure here indicated is 1 atmosphere. You need to convert that to Pascal by multiplying by 10 to the power of 5. That is an approximate value. So multiply the gauge reading by 10 to the power of 5 to convert it to Pascal. Okay, so we will have the reading when the bulb is covered in ice. Then I will heat it, and you will take measurements for every 10-degree rise in temperature. So your temperature values will be 0 degrees, 10 degrees, 20, 30, 40, up to 90, maybe you can go up to 96 or so. You will never be able to reach 100. Now we will also take the pressure readings while we allow the bulb to cool down, so that for each temperature you have 2 pressure values. Take the average. Now that will eliminate the errors that are present in this experiment. There are of course a lot of errors in all these experiments. Well, that will be the experiment. I will set it up and allow you to take the readings as we go on. So PV equal to nRT, we will change the temperature and measure the corresponding pressure, and that pressure will be directly proportional to the absolute temperature when the volume is a constant. Alright, how does this become of the form y equal to mx? Solve for the dependent variable. Temperature is the independent variable, pressure is the dependent variable. So you got pressure equal to, volume is a constant. We got nR divided by V multiplied by T. So you got y equal to mx. If you now draw a graph of pressure in Pascal on the y-axis and temperature in absolute scale, in Kelvin scale, on the x-axis, the graph will be a straight line. And the slope of that graph will be nR over V. Now, if you know the value of V, the volume of the air inside, I have given you on the lab manual, in the lab manual, the inner radius, inner diameter of this bulb. Now, if you know the radius of a sphere, can you calculate its volume? What is the volume of a sphere? Well, all calculus and physics students should know that. I have given it to you in the lab manual anyway. So calculate the volume of the air. So we know it. You know the value of R. You can calculate N. So obtain the slope of the graph and set it equal to this quantity and obtain a value for N. That is the first purpose of the experiment. Now, I also said we will also attempt to obtain a value for absolute zero. Now, how can that be possible? Now, this equation I can also write, remember, absolute temperature T is temperature in degrees Celsius plus 273. Is that right? So, if you replace the uppercase T by this, what will the equation become? We got PV equal to nR times 273 plus T. Now, this now becomes, let me write it here, PV equal to 273 nR plus nR times T. Alright, now this equation is now of the form y equal to mx plus b. You see that? Look at that, I'm going to write it. Y equal to mx plus b. Now, b is the y-intercept. That means this will be the y-intercept of your graph. If you draw this time a graph of p against t. But we need to rearrange this equation one more time. Solve for p. Alright, I'm going to solve for p and write it here. So p will be equal to 273 nR over v plus nR over v times T, where this T is in degrees Celsius. So, if you now draw a graph of P in Pascal, absolute values, against the temperature in degrees Celsius. Remember our first graph, we used the temperature in Kelvin. And that graph passed through the origin because pressure is directly proportional to the Kelvin temperature. But this time we are using the temperature in degrees Celsius. Pressure in Pascal. Now, this graph will have a y-intercept, and that y-intercept will be 273 nR over v. And its slope will be nR over v. The same slope as we had before. So, the graph will be like that. Okay, now I want you to measure the y-intercept and set it equal to this quantity and obtain a value of n, the number of moles from there. So, you can get two values of n from this graph. Measure its slope, set it equal to nR over v, and calculate the value of n. Obtain the y-intercept, set it equal to 273 nR over v, and also get a value of n from there, and obtain the average of the two. Well, if you now extrapolate this graph, it will meet the time, the temperature axis at the absolute zero. Now, in order to do that, you must take care in your scale, because the temperatures that we used in the experiment is from 0 to about 100. And this graph, when extrapolated, is going to meet the x-axis at, almost negative 273. That means you need a lot of space to the left. So adjust your scale. I want to see your skill in doing that. If you can do this graph on a piece of paper and scan it or mail it to me, just ordinary mail, I want to see how you do that. Alright? If you do a good job of it, I will even give you up to 5 points extra credit for this. Okay? So, if you extrapolate this, it will meet the x-axis at the absolute zero. And measure that and find out what that absolute zero is. Well, it has to be negative 273, is that right? And I want you to obtain a percent difference or percent error, knowing that this is the actual value. Use the actual value and the measured value and obtain a percent error. Alright? And now I'm going to set up the equipment and I'm going to allow you to take the readings corresponding to each temperature, the pressure values, and once it is all done, prepare your lab reports and upload it. Alright, any questions, anytime, either email me or contact me through the discussion board. Now remember, the discussion board is a way to communicate among yourself and also between you and me. And I will be reading all your postings. And if you need any help from me, I will be able to give it to you there. Okay, let's start the measurements. I have now set up the equipment and we will start taking the reading. Now notice that I have focused the camera on the gauge. Now what you see here is readings in actually atmosphere. Well, this is 1 atmosphere, so when you take the reading as 1, you need to multiply it by 10 to the power of 5 to convert it to Pascal. So that will be, that's 1.5, so that will be 1. Is that 02, 04, 06, 08? Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. These 10 divisions are divided into, this 0.5 is divided into 10, so each is 0.05. 1.05, 1.1, 1.15, 1.2, 1.25, and so on. Now, each of the reading you need to multiply by 10 to the power of 5 to make it a Pascal. Now, because I cannot focus on the camera, on the gauge and the thermometer at the same time, I will have to quickly move the camera from the thermometer. So what I will do is I will allow you to take the temperature reading. Now look at the thermometer readings there. That'll be 20, each is a degree. So try and take the temperature reading as closely as possible. I want you to take the temperature reading every 10 degrees Celsius and the corresponding pressure. Well, there may not be a lot of variation, but try your best. Now this is how I'm going to set up the scenario. Now when the temperature reaches, say, when the temperature is 0, we will start there. I will move it down so that you can take the pressure reading. Alright? Okay, I'm going to now cover the bulb with ice so that the temperature reads 0. Let's see if that can be done. The temperature doesn't seem to be going below that level of 1 degree. What I will do is I will heat the system now so that the temperature will increase, and I would want you to take the pressure reading, say, every 15 degrees Celsius. Otherwise, it may be difficult to get any measurable readings. All right, so this is the temperature. Take the first temperature, and I'm going to show you the pressure gauge now, and take the pressure value. All right, there we go. That's the pressure for that temperature. Okay, now you need to wait for me to heat the system to about 15 degrees Celsius, and I'm going to do that. All right, measure the temperature now. Take this temperature. I hope you've done that. And I'm going to show you the pressure gauge now. All right, measure the pressure now. You've got to be very creative in measuring that pressure. All right. So you got that temperature and the corresponding pressure. All right. Alright, we are getting ready to take the next temperature reading. Take that convenient value. Wait for. Alright, take that temperature and the corresponding pressure. Take that reading quickly. It will change now. Okay. Alright. Wait for the next temperature. Well, we seem to be taking readings every 10 degrees Celsius. Take this temperature reading now. Okay. And take the corresponding pressure value. Read it carefully. You can stop the video and take that reading. Alright, we will allow the temperature to increase now to the next value. We are now getting ready for the next temperature reading and the corresponding pressure. Alright. Read the pressure corresponding to that. Stop the video and take that reading. Okay. Getting ready for the next temperature reading. Alright, read the corresponding pressure. There we are. Okay, get ready for the next temperature reading. The temperature increases more slowly as the temperature becomes higher and higher. You need a lot of patience for an experiment like this. All right, now let's go and read the pressure. Okay. We are now getting ready for the next temperature reading. I'm trying my best not to shake the camera, but because it is focused to the maximum, any small disturbance will shake it. All right, let's go and read the pressure value there. Measure the corresponding pressure there. We are now getting ready for the next temperature reading. All right, let's take the corresponding pressure value now. You need to be a little creative in reading this. I have been waiting for about half an hour to see if the temperature will increase any further. Since it doesn't, this is going to be our last reading while the temperature is rising. So let's take the pressure reading now. There you are. Take that pressure reading. Now, to compensate for the errors that we may have caused, and you know there are many errors in the experiment. Now what we're going to do is, we're now going to allow the bulb to cool down and take the readings as the temperature falls. For the same temperature, we will take the pressure values once again and take the average. All right, let's do that. As the water cools, we are now approaching our next temperature reading, so I want you to take the pressure corresponding to this temperature. Let me see if the pressure gauge is properly readable. All right. It's slightly tilted. Okay, let's read the pressure corresponding to this temperature. There you go. Take that pressure value. This is the pressure values when the temperature is decreasing. We will finally take an average of the two pressure values. Well, we are nearing the next temperature reading, and we will measure the corresponding pressure. Okay, there we go. Measure that pressure value. Okay, we are now ready for our next temperature pressure readings. sometimes it could be a long wait. All right, now let's measure the corresponding pressure. There you go. Measure that pressure value. We are ready for the next temperature reading. Am I right? Okay, let's go. Take that pressure value. In about a couple of weeks, we will discuss a relation between the rate of cooling of a hot object and the temperature of that object. And what you will see is that the rate of cooling will become less and less as the temperature falls. That means it's going to take a very long time for us to reach 50, 40 and so on. Now, it is your lab partner who suffers, because for you it doesn't take a long time, does it? We are now getting ready for the next temperature pressure reading. Okay, let's see. Well, that's the pressure reading corresponding to this particular temperature. Okay. We have now almost another temperature pressure reading. All right, you have the temperature. Let's look at that pressure. There we go. Okay. It will be another half an hour wait for me to cool down, but I'm actually cooling it down a little more artificially by adding more cold water and ice in a systematic way. I cannot do it fast. Alright, you can see the cooling rate is very, very slow now. The temperature is still the same, and of course the pressure hasn't changed. Okay, let's wait to cool down for another 10 degrees. Well, are we nearing another temperature pressure reading? Okay, I added some ice water, so we wait for it to reach that equilibrium temperature. So it's not going to change from this for quite some time. All right, let's measure the pressure value now. There we go. Has it changed any at all? Okay. You can see the temperature hasn't really changed much. Okay, we will cool it down further. I don't think we will be able to reach back to zero, but we will go as far as we can go. Ready for the next reading. It doesn't matter, it's a little lower, but it doesn't really matter. Let's take the pressure value. There we go. That's the pressure value for that temperature. Okay. You can see the temperature hasn't really changed for the last 15 minutes. See what the pressure is like? Has it changed? Not really. Okay. I'm going to see if I can get a reading for 10 degrees or close to 10. Okay. I'm going to see if that's possible. If it is not possible, we will stop here. I think we are coming closer to where we want to go. I want to stir some more ice in it. The sound you hear is the sound of my stirring the mixture. You can see the temperature is coming close to 10. Alright, let's take the pressure value corresponding to that temperature. There we go. Okay. So we have a large number of readings now. Make sure that you take the average values for the two readings that we have got for many temperatures. Okay, you are now ready to complete the lab and send me the report.